So let's work on section 3.9, application of Extrema. And here is the first question. It's telling you find the minimum distance from the point to the plane x minus y plus 6 plus z equals 6. So the first one is we have the plane is x minus y plus z equals 6, and the point is 0, 0, 0. So let's, first of all, this is x1, y1, and z1, and we need to find the distance. So I'm going to find the critical point from this one, and I'm going to use the critical point to find the distance between this plane and this point. So I'm going to say here, x2 equal x, and y2 equal y, and z is going to be z2 equals z, which is here. I'm going to solve this one for z. So it's going to be 6 minus x plus y. So this is z2. You can say z2 or z. Now, the next step, we're going to use the distance formula. The distance formula, d equal square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Before I keep working on this one, I'm gonna take square both sides. So d squared is going to be x2, which is x minus x1 is 0 squared, plus y2, which is y minus 0 squared, plus z2, which is 6 minus x plus y minus 0 squared. That means d2 is going to be x squared plus y squared plus 6 minus x plus y squared. And you don't have to simplify this one. We're just going to say our function with x, y is going to be x squared plus y squared plus 6 minus x plus y squared. Now then, next step, I'm going to find the derivative with respect to the x and the y to find the critical point. So f sub x is going to be 2x plus 2. This is 0, so it's going to be 6 minus x plus y times the derivative of inside, which is with respect to the x is -1. I'm going to simplify this one. So it's going to be 2x plus 12. Be careful here is -1. -1 times 2 is -2. So it's going to be -2 times 6, -12, plus 2x minus 2y. This is f sub x. That means f sub x is going to be equal. We're going to combine the log terms. So it's going to be 4x minus 2y minus 12, and that's it. This is f sub x. Now we need to find f sub y is going to be equal. This is 0, so it's going to be 2y plus, and here is 2, 6 minus x plus y times the derivative of inside with respect to the y equal 1. And this one equal 2y plus 12 minus 2x plus 2y. Then combine the log terms. That means f sub y is going to be equal 4. I'm going to write down the x first. So -2x plus 4y plus 12. Okay, now to find the critical point, we're going to let f sub x equals 0 and f sub y equals 0. That means this one's going to be 0, so we're going to get 4x minus 2y minus 12 equals 0. And the second one is going to be negative 2x plus 4y plus 12 equals 0. I need to solve this system. So I'm going to multiply the second one by 2. That means our system is going to be 4x minus 2y minus 12 equals 0. And the second one is going to be negative 4x plus 8y plus 24 equal 0. Cancel these. So it's going to be 6y equal 12. That means in this case, y is going to be equal. Here is the wrong thing because I need to move this one. It's positive 12. That means 6y plus 12 equals 0. So 6y is going to be equal negative 12. Y is going to be equal negative 2. Now plug in negative 2 in the first equations. So 4x minus 2 times negative 2 minus 12 equals 0. That means 4x, 4 minus 12, 4 minus 12 is going to be negative 8. That means minus 8 equals 0. That means x is going to be 8 divided by 4 is going to be 2. Let's see here. No, negative 4 minus 12. This is negative 2. Plug in here. Let's keep going. So y equal negative 2 and x equal 2. Plug in x and y in the z. That means z is going to be equal 6 minus x is 2 minus y is negative 2. So plus negative 2. That means 6 minus 4 is going to be 2. So the critical point is x is 2, y is negative 2, and z is 2. Now to find the distance, you don't have to check it's a maximum or minimum. You're just going to find the distance between this point or on the initial point. So there's going to be the distance equal square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. And then the distance is going to be square root of 2 minus 0 squared plus y is negative 2 minus 0 squared plus, and the z is also negative 2 minus 0 squared. Is going to be square root of 4 plus 4 plus 4. And this one is going to be square root of 12, which is the square root of 4 times 3, which is equal to square root of 3. That means the distance between this point, the critical point, which is on the plane, and the initial point is going to be 2 square root of 3. So we're just going to type here 2 square root of 3. . We got it right. Let's go to the next question 2. Question 2, find the minimum distance between the point and this plane. We're going to do exactly the same steps. So this one is x1, y1, z1. I'm not going to write down the formula and the square root. I'm going to use x2, which is equal x, and y2 equal y, and z2, which is the z equal 2 minus x plus y. I'm going to use these. I'm just going to say d squared, which is the same thing what we did on the previous example. It's going to be x minus x1, now it's 6 squared, a plus y minus y1 is 0 squared, plus z minus z1, which is 7. Z is this amount, which is 2. First of all, I'm going to write it down, z minus 7 squared. Then d squared is going to be x minus 6 squared plus y minus 0 squared plus z, which is 2 minus x plus y minus 7 squared. Then d squared, which is our function, I'm just going to write down the function, x minus 6 squared plus y squared plus combine 2 with negative 7, so it's going to be negative x plus y minus 5 squared. That means our function f to the xy is going to be x minus 6 squared plus y squared plus negative x plus y minus 5 squared. Then you're going to find f sub x equal the derivative with respect to the x, 2x minus 6. The derivative inside with respect to the x is 1. So plus, this is 0. Derivative for this one is going to be 2 negative x plus y minus 5 times the derivative of inside is negative 1. So this one is going to be, let's distribute this one. So it's going to be 2x minus 12. Negative 2, be careful here, is negative 2. So negative 2 times x is going to be positive 2x. Negative 2 times 1 minus 2y plus 10. That's mean f sub x, which is going to combine the log terms. So 2x is going to be 4x minus 2y, and negative 12 plus 10 is going to be minus 2. Now I'm going to do it right away. F sub x equals 0. That means it's going to be 4x minus 2y minus 2 equals 0. And I say this is the first equation. The second one, we're going to find f sub y, which is equal. This is 0, so it's going to be 2y plus 2, and here is negative x plus y minus 5 to the 1, and derivative of inside is 1. Let's simplify. So this one is going to be equal 2y minus 2x plus 2y minus 10. Yes, minus 10. Combine the log terms, that means f sub y is going to be negative 2x plus 4y minus 10. Let f sub y equal 0. That means we're gonna get negative 2x plus 4y minus 10 equals 0. This is the second equation. Let's write down these two equations here so we can work on the system. 4x minus 2y minus 2 equals 0. And the second one is negative 2x plus 4y minus 10 equals 0. Now we need to solve this system. So we're going to multiply the second one by 2. That means the whole system is going to be 4x minus 2y minus 2 is going to be equal 0. And here is negative 4x times 2 plus 8y minus 20 equal 0. Now we're going to combine these two systems. So it's going to be 8y minus 22 equals 0. That means y is going to be equal 22 over 8, which is equal, sorry, this is not 8y, this is 6 plus negative 2 plus 8. So divide by 2, so y is going to be 11 over 3. Plug in the y in one of these equations. 4x minus 2 times 11 over 3 minus 10 equals 0. And we need to solve this one to find the value of y. So this is 4x minus 22 over 3 minus 10 equals 0. Now we need to solve this one. 4x minus 22 over 3 minus, I'm going to multiply by 3. So it's going to be 30 over 3. Here's the wrong thing. I'm multiplying, I'm plugging on the first one. So this is minus 2. This is minus 2. That's mean multiply by 3 is going to be negative 6 over 3 equals 0. That's mean 4x is going to be equal, just what I'm going to say, minus 28 over 3. Equals 0. And this one is going to be 4x equal 28 over 3. That's mean x is going to be divide both sides by 4. Flip the 4 is going to be 28 over 3 times 1 over 4. And this one is going to be equal 28 divided by 4 is going to be 7 over 3. So this is the value of x. Now plug in x and y to find the z. Our z is going to be 2 minus x is 7 over 3 plus y, which is 11 over 3. Combine these together. So it's going to be 2 minus or plus 4 over 3. Now let's combine these together. That means this one is going to be equal, multiply by 3. So it's going to be 6 over 3 plus 4 over 3. And this one is going to be equal 10 over 3. So this is the value of z, this is the value of x, and this is the value of y. That means our critical point is going to be x is 7 over 3, and y is 11 over 3, and z is 10 over 3. Now let's go ahead and find the distance. So the distance is going to be square root of x2 minus x1. So 7 over 3 minus 6 squared. And plus y2, which is 11 over 3, minus y1 is 0, plus z2, which is 10 over, minus z1 is 7 squared. Combine the like terms, find the common denominator. So here is going to be 7 over 3 minus 18 over 3 squared. Plus, this is 11 over 3 squared. Plus, this one is 10 over 3 minus 21 over 3 squared. And the result is going to be square root of this one. 7 minus 18 is going to be 11 over 3, negative 11 over 3 squared, plus 11 over 3 squared, plus 10 minus 21 is going to be negative 11 over 3. And then the distance is going to be square root of 121 over 9 plus 121 over 9 plus 121 over 9, which is equal the square root of 121 plus 121 plus 121 is going to be 363 divided by 9. And this one is going to be 363 divided by 3. We can divide by 9. So it's going to be 121 over 3. And there is a root for 121, which is 11. And keep the 3 here. You can rationalize. And if you just keep it like this, it's going to be right. So this is example 2. So we're just going to type here 11 over square root of 3. Let's check that. We got it right. That's it for this example. So example 3, find the minimum distance of the point to the surface. Now it's a surface, not a plane. And here is our initial. So we're going to do the same thing, the same steps. So the example 1 and 2, I'm going to say x2 is going to be equal to x. y2 is going to be equal to y. And z, in this case, is going to be the surface here, which is 4 minus 2x minus 2y. So here's our z. So now let's work on this one. We're going to do the same thing, the distance squared. We're going to say the distance is going to be equal square root of x2 minus x1 plus y2 minus y1 squared plus z2 minus z1 squared. And the distance is going to be equal d squared. I'm going to write down right away. I'm going to square both sides. So d squared is going to be x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. And then Next step, I'm gonna plug in. So d squared is going to be x2, which is x minus x1. So it's going to be plus 2 squared, plus y2, which is y minus y1. So it's going to be plus 2 squared plus z, which is the square root of this one. So it's going to be the square root of 4 minus 2x minus 2y squared minus 0. So now our function d2 is going to be equal x plus 2 squared plus y plus 2 squared plus this one minus 0 and squared. So it's going to be 4 minus 2x minus 2y. That's mean f to the xy is going to be x plus 2 squared, y plus 2 squared, plus 4 minus 2x minus 2y. Now here is our function. Now let's find the derivative with respect to the x to find the critical point. So f sub x is going to be 2 x plus 2. Derivative of inside is 1. This is 0. And here is negative 2. So this one is going to be minus 2. Because this is 0, this one is a constant, so it's going to be 0. Now f sub y is going to be, this is 0, so it's going to be 2 y plus 2, 0, 0, and negative 2 times 1 minus 2. F sub x, we're just going to simplify it. So it's going to be 2x plus 4 minus 2. And this one is going to be equal 2x plus 2. F sub y, we're going to simplify it. So it's going to be 2y plus 4 minus 2. And this one is going to be 2y plus 2. That's mean critical points. So we're going to let f sub x and f sub y equals 0. So the first one is going to be 2x plus 2 equals 0. That's mean x is going to be equal negative 1, because negative 2 divided by 2 is going to be negative 1. And f sub y, that's mean 2y plus 2 equals 0. So y is going to be equal negative 1. So now we have x equal negative 1 and y equal negative 1. To find the z, we're going to plug in these here on the z function. So z is going to be equal square root of 4 minus 2 times negative 1 minus 2 times negative 1, which is equal square root of 4 plus 2 plus 2. So the square root of 8, which is equal to square root of 2. So this is the z. That's mean our critical point. X is negative 1, y is negative 1, and z is 2 square root of 2. To find the distance between this point and is going to be the square root of x2 negative 1 minus x1, which is negative 2 squared, plus y2, which is negative 1, minus y1, which is negative 2 squared, plus z, which is 2 square root of 2 minus z1, which is 0. So the distance is going to be square root of negative, this is going to be 1 squared here, because negative 1 plus 2 squared, plus the same thing here, negative 1 plus 2 squared, plus 2 square root of 2 squared, which is going to be equal 1 squared plus 1 squared plus 4 times 2 is going to be 8. So the result is going to be square root of 1 plus 1 plus 8, 10. So this is the distance between the surface and the point. So the distance here is going to be square root of 10. There we go, square root of 10. So let's go to example 4. A home improvement contractor is painting the wall and the ceiling of the rectangular room. So here's the rectangular room. The volume of the room is 989.25. So I'm just gonna write down this information. That means the volume is 998.25 and cubic feet. The cost of wall paint is 0.12. So the cost of wall is going to be 0.12 feet square foot. So square foot, and the cost of ceiling paint is 0.80. So cost of the ceiling is going to be 0.18 square feet. Okay, so that's the only information we have. Let's see, find the room dimension that result in the minimum cost for the paint. So we need to find the dimension, then the minimum cost. So here is the thing, we don't have, first of all, we need to find the total cost is going to be, that's mean the cost for paint everything except the floor, because we're not gonna paint the floor. We're just going to paint the walls, which is 4 sides, and the ceiling. So it's going to be the cost of painting the wall plus the cost of painting the ceiling. Now let's find out how we're gonna find the cost of painting the wall. So the first thing here, our cost is going to be the cost of painting the wall. So the wall, this is the height Z, this is the width, you can say X, or let's say the width Y, and X is the length. So it doesn't matter if you choose this is X, it's gonna be the same thing. So now, how many sides do we have with the walls? We have one side of this wall, which is YZ. And I have this side and the other side of the room, YZ. That's mean is going to be the paint, which is 0.12 times 2YZ. 2YZ plus the other side is 2. This is also Z, and I have 2 sides, so 2XZ. Let's write down the XZ first, and 2YZ plus the cost of the ceiling. We already know the cost of the ceiling is going to be exactly like the floor, which is this one similar to this one. That's mean this is X and the width is Y. So we're just gonna find the ceiling, not the floor. So I'm not going to say 2 times xy. I'm just going to say 0.18 times the ceiling, which is xy, because we're not going to paint the floor. Now let's keep going on this one. Multiply 0. This one is going to be C equal 0.12 times 2 is going to be 0.24 xz plus 0.24 yz plus 0.18 xy. Now we're done. We're going to stop until here. We're going to use the volume because I already know the volume of rectangle is the length times the width times the height. The volume is 998.25 equal the length, which is x, the width is y, and the height is z. I'm going to solve it for one of these variables. So let's solve it for z. We always solve it for z. That means our z is going to be equal 998.25 divided by xy. Now let's plug in the z here to find our equations. The cost is going to be 0.24 x times z, which is 998.25 divided by xy plus 0.24 y, and the z is 998.25 divided by xy plus 0.18 xy. There is no z on the last part. Cancel the x with the x, y with the y. Multiply these two numbers. So let's multiply the cost C is going to be 0.24 times 0.24 times 998.25 is going to be 239.58 divided by y plus the same thing here is going to be 239.58 divided by x plus 0.18 xy. Let's keep going. Now, this is our function. It's hard to find the derivatives with respect to the x and the y. To make this one easier, I'm going to move y on the top and x on the top. So C is going to be 239.58 y -1 plus 239.58 x to the -1 plus 0.18 xy. Now C sub x is going to be, this is 0. This one is going to be negative 239.58 x to the -2 minus, this one is going to be plus 0.18 y. This is the first equations, and this one is going to be equal, bring back this one on the bottom. So negative 239.58 over x squared plus 0.18 y. This is our first equation. Now C sub y is going to be, in fact, let me plug in C sub x equals 0 to find the first equations. That's me. Let C sub x equals 0 to find the first equation. That's mean this one is going to be equal 0. So negative 239.58 over x squared is going to be plus 0.18. Y is going to be equal 0. Here is our first equation. Now let's check to find the second one. C sub y is going to be, here is our function to the y, this one. So it's going to be negative 239.58 y to the negative 2 plus 0.18 x, which is this one is going to be equal negative 239.58 over y squared plus 0.18x. C sub y equals 0. That's mean this one equals 0. So negative 239.58 over y squared plus 0.18x equals 0. Let's keep going. Now we have two equations. I'm going to solve this one for respect to the y. So we solve this one with respect to the y. I'm going to solve this one with respect to the y. So from 1, in fact, you can solve any one for the variable x or y. I'm going to solve this one for the y. Must me move this one to the other side of this equation, move this one to the other side. So 0.18 y is going to be 239.58 divided by x squared. Now multiply or divide both sides by 0.18. That's mean y is going to be equal if I divide this number, which is 239.58 divided by 0.18 is going to be, second. Let's keep going. So divide this one by 18, because you're going to divide the whole thing by 18 to bring this one and the flip. It's going to be 1 over 0.18. So this one divided by 0.18 is going to be 1,331 over x squared. Now I'm going to plug in this one on the second one. So when you plug in the second one, that's mean here. So this number is going to be plug in everything here instead of the y squared. So negative so it's going to be plug in here. So negative 239.58 divided by 1,331 squared plus 0.18 x is going to be equal 0. I'm going to multiply everything 1 second, by x squared. 1331 over x squared squared. So it's going to be negative 239.58 over, I'm going to keep this number 1331 squared over x to the power 4 plus 0.18 x equals 0. Now, next step, what I'm going to do, I'm going to multiply everything because we're going to bring down this one, flip this one. So the result is going to be x squared, x to the power 4 over this big number times negative 2.3. Yeah. So I'm going to keep this one. This one is going to be negative 239.58 over 1 times x to the power 4 over 1331 squared plus 0.18 x equals 0. Now I'm going to take x as a common, or we can take, let's cancel this one. So I'm going to multiply the whole thing by this big number. And let's see how much is going to be the result. So multiply everything by this number. That means is going to be negative 239.58 x to the power 4 plus, I'm going to multiply 0.18 by 0.18 times 1331 squared, and it's going to be this big number, which is a 3,188,0.98 equal 0. Now I'm going to take, oh, here's the x. Negative 239.58 x as a common. The left here is x cubed. And now this big number, if you divide it by, we're going to take the negative, so 239.58 is going to be minus 1331 equals 0. Now, negative 239.58 x equals 0. That means x equals 0. We can't choose this one because we have a room with length positive number, not equal 0. So we can't choose this side. And the other side is going to be x cubed minus 1331 equals 0. That means x cubed is going to be 1331. Take the cubic root for both sides. That's mean, let's take the cubic root. 1331 is going to be 11. So we found the length of the room. It's 11. Plugging in the y, because we already have the y equal 1331 divided by x squared, which is equal 1331 divided by 11 squared is going to be 1331 divided by 121, and I think it's going to be also 11. 1331 divided by 121 is going to be also 11. That means it's a cubic. The xy, x equal y, and now we need to find the z. So z equal 998.25 divided by xy, which is equal 99.8.25 divided by 11 times 11, which is going to be equal 998.25 divided by 121 is going to be 8.25. So our z coordinate, which is the height, 8.25 feet. So now we have the dimension of the room. That means we're going to plug in the sides, which is xy, just 11, and the height is 8.25. Now we need to find the minimum cost. We're going to go back to our equations, which is this one. Because we have the sides, now we have the dimension of the room. So we're just going to plug in everything here to find the minimum cost. So the C equal 0.24 times X, which is 11, and times Z, which is 8.25, and plus 0.24, Y is 11, and Z is 8.25, plus 0.18, XY, X is 11, Y is 11. Now let's plug in everything here. That's mean is going to be 0.24 times 11 times 8.25 plus 0.24 times 11 times 8.25 plus 0.18 times 11 times 11. It's going to be 65.34. 65.34. So the minimum cost is going to be 65.34. This is the minimum cost, and we already typed the dimension. So I'm just going to type here 65.34. Here we go. We got it. Now, example 5. So a corporation manufacture candle at 2 locations. The cost of producing X1 unit at location 1 is this one. On location 2 is this one. The candles sell for $17 per unit. Find the quantity that should be produced at each location to maximize the profit. And we have here's the equations. So what we're gonna do here, we're gonna plug in C1 and C2 here, and we need to find the candles produced in first location and the number of candles produced on the second location. So the first thing here, what I'm going to do, I'm gonna simplify this one, which is equal, distribute the 17, so the 17x1 plus 17x2 minus C1 minus C2. And then next step, we're gonna plug in C1 and C2 here. That means P is going to be equal 17x1 plus, I need to write down smaller. So P is going to be equal 17x1 plus 17x2 minus C1. Be careful because negative sign is going to be distributed on all C1. So it's going to be negative 0.02 x1 squared minus 4 x1 minus 590 minus C2, so it's going to be minus 0.05 x2 squared minus 4 x2 minus 250. Combine the like terms, that means our P is going to be 17x1, and here is negative 4, so I'm going to say negative 0.02 x1 squared plus 13x1, because 17x1 minus 4 minus 0.05 x2 squared, 17x2 minus 4, so plus 13x2. And we still have negative 59 minus 250, so it's going to be minus 8, 5, 700, 840. Yes. Now we're going to find the derivative with respect to the P1. Sorry, to the X1. To the X1 is going to be as X1 as a variable, not X, Y, Z. So this one is going to be 2 times, so it's going to be negative 0.04 x1 plus 13. This is 0, this is 0, this is 0. P x1 equals 0. That's mean negative 0.04 x1 plus 13 is going to be equal 0. Now it means negative 0.04 x1 equal negative 13. Divide both sides by 0.4. So x1 is going to by negative 0. Let's see how much is going to be. 13 divided by 0.04 is going to be 325. That means x 325. Now let's find P2. That means P x2 is going to be, this is 0, this is 0, is going to be 2 times 0.05, so it's going to be negative 0.1 plus, x2 plus 13 is going to be equal. That Px2 equals 0, that means negative 0.1 x2 plus 13 is going to be equal 0. So negative 0.1 x2 equal negative 13 divided by negative 0.1. That means 13 is going to be 130 divided by 0.1. It's going to be 130. So that's how many candles to get the maximum profit. So X1 is going to be 3 at the first location, 325. And here is going to be 130. Here we go, we got it right. That's it for this section, section 13.9.